Hello everyone, welcome to the mask detection project where we will classify the faces of a person who are not wearing mask, and we will also match their faces with the existing database which we have. So in this specific project, the two important libraries which we have used is TensorFlow and MTCNN. So TensorFlow is basically a DL framework which we have used to build the models. The other one is the MTCNN. So MTCNN is also a pre-trained model where it identifies or it will detect the faces present in the image and gives us the crop images from it. Here I am importing the necessary libraries and defining my model. You can also go for pre-trained models like ResNet, VGGNet, InceptionNet, MobileNet, and many others. So here are like 13 million parameters I have. Here is the structure of my model. Here are the utils function that are like data pre-processing and data loading utils functions which we have defined. The other one is the distance. So basically we are using a Siamese network. So over here we are using the Euclidean distance to find the dissimilarity between the two faces, or we can say between the two images. So lesser the score, or we can say lesser the distance between two images, the more it will be same, whereas if as the distance increases, the images are quite different. I will explain it after the result part. So over here is the batch processing function, normalization function, and okay, so here I have defined the positive anchor images, negative anchor images, and the anchor images. In that way I have defined my batches. So the dataset which we are using in this specific project is celebrity face detection project, celebrity faces dataset, and it's like 900 images which we have, and among them it's RGB images we have, and its resolution is 160 cross 160. So after the defining model and the training starts, so after the 100 epochs we are getting nearer to 5.3 as our loss. It's quite big, so we can also increase the number of epochs to get the to also optimize our model more. So as this graph shows that how the triplet loss and epochs goes, so like graph is still approaching towards the zero, so the model did not start overfitting, as like from analyzing the graph we can say it simply. So here is the result. So these two images are of the same person, so the distance among them is close to zero, whereas these two images, anchor and negative images, are different, so its score is higher than 1. So in this project we have considered 0.3 as our threshold. So if the distance between two images is nearer to 0.3 or lesser than 0.3, that two images or that two faces, like that specific person faces, matches within the image of our database. So after that we have saved the weights. So the motive of this model is we have a pipeline. So first of all, after the face mask detection algorithm works, we will see that whether the person is wearing a mask or not. If person is not wearing a mask, we will share them a mail describing at what time they are not wearing a mask, and there will be the fine, like what will be the fine they have to pay to the college. In that way, for that specific reason we are using this. So anchor images we have in our database through ID card images, and these are the real-time images which we got from the camera feed from the Nvidia Jetson. For the second model in our pipeline is the mask detection model. So basically we have get the dataset from the Kaggle, like it's a collection of images with the labels that whether the person is wearing a mask, like its folder name is with mask and other one is without mask. So we have labeled them as 0 and 1 through image directory, and we read the images and we resize the images as 160 cross 160 RGB images, and we have saved it in our NumPy array, and also we have normalized that NumPy array as well by dividing by 255. If we don't normalize these images, then the loss will be huge compared, because the values are like in hundreds, and it's just obvious that it will create a huge loss value. So if we keep all the values between 0 to 1 through this thing, we will decrease the loss value as well. And okay, so after that we have just converted the 0 1 array to a categorical array. So like to categorical, for example, in the previous, where before the categorical it's like x, if the number of images is x, then this specific is array, like matrix dimension is x cross 1. But after two categorical, its dimension will be like x cross 2 cross 1. So like two arrays, if a label is 0, then at the 0th index it will be 1, else if it will be at 1th index it will be 1. We have saved the array for future use. So like now I am defining my model. So it's a simple model with a 2 convolution layer and 2 dense layer. So 2 is basically used because we have 2 labels, and softmax is a parameter for finding a category. Like it over here we can also go for sigmoid and binary cross entropy with one neuron, but we have preferred this way because it's giving us the good result. So our optimizer is Adam, and matrix accuracy, like based on which the training, like back propagation should be done, is our accuracy, is our matrix. We have splitted our data set and take the train and test into a train and test data set. After that we have started the epoch. Like yes, the for the represent part only I have run this notebook, but the model which we have in our h5 file is trained for a 20 epochs. Through callbacks we can monitor our validation loss. So if the validation loss decreases compared to the previous one, it will save the weights at that specific instance only. And now I have just implemented a util function for the testing part. So for a specific image we got the scores like this, 0.04 and 0.95. So higher the score, that specific label is activated. So the 1th index is for without mask, so the image which we inserted is without mask and its label is also correct. So over here is the our completion of mask detection model as well. And now in the third part we will see that how both of these, sorry for this notification. So in the third module we will see that how both of these models are combined together in a pipeline to work as a whole. Thank you. Hello everyone, I will explain that how we have combined both of these model into a specific pipeline through which we can carry out whole task within the one go. So I have just imported my model weights, and first of all I have defined my two subsequent models and imported their weights within this, and after that over here is the main function which is go through. So first of all, file name. So it is like a frame, whether this can be as a video file or a single image file, either way this will be go fine. So it's a path of that particular file. After that the size, like for the reshape part, it's for that thing it's 160 cross 160, and then whether we should normalize this given image or not, like divided by 255.0. So first of all we have converted the image into an RGB image. If somehow in some case if the given image is grayscale, then we have to convert it into the RGB. So we have converted this image and considered it as an array. Then empty CNN function, which I have already described, that it gives us the faces from that thing. It will give us the faces, and so here is the face, and it's kind of, we will iterate through each of the faces. In that way we will return the face array. So now the file name starts and the detection process starts. And we have also, like if the somehow a new entity is added, then we also have to fine tune the weight. So the other, like these are the this recognize function is for that specific task, that it will get the known face IDs and match with the new one. Like in my, there are 10 specific images data set I have, and from that it will compare this new face with each and every one of them and give us the score. Like that score where I have already described in previous module, that we get the zero, like score, like distance between the two images. If they are similar, we will get the score nearer to 0, else it will be greater than 1. Over here is the mask label. So this specific function will predict that whether a given person face has a mask on it or not, and it will return its label. So here is the main function where whole the process is goes on. So mode is for the whether it's a webcam, video, and other things. So HR, like the detector is like the face detection, like we are using the cascade or cascade. In that way we can also define that thing. Over here the threshold is 0.75. You can change this value for to get the better performance as well. Known phase encodings is the matrix we pixel matrix we have in our database, and known face IDs are their specific name or a roll number or any unique ID we have. So over here, as the frames comes, we extract the phases from the empty CNN and we just start to process it. So if mask label we will get, so if the mask label is like 0, if the mask label is 0, then the person is wearing a mask, so it will put a green color rectangle box on it. Else if the person is not wearing a mask, it will put a red color rectangle box on it with a label, like the label of 0 is the person's name. This label over here, by within the condition we can put some function where it will send mail to label 0's email ID, and through that the person can get to know that whether he was wearing a face mask or not. In that way the whole project is working. And now in the subsequent models I will explain how we can deploy this whole model into a Nvidia Jetson. So thank you.
So yes, here is the third part of our work. So like now, like okay, I have created my two subsequent models that are required for my project. Now I also have to deploy this at a specific platform. So for the deployment part, we cannot simply create a simple PC and put over there. It might get the cost higher. So like we can use some kind of tools, like we can create a cloud type. We can use a Raspberry Pi as our hardware where we can use the cloud VMs. The other way around is we can use the Nvidia Jetson where we get the dedicated GPU. So like okay, I do not have to set up the cloud VM. I can easily do the work on my Nvidia Jetson because it provides me a GPU, like a dedicated Nvidia GPU on which my each and every models can be run easily. So like to communicate with this Jetson, the other way is like the specific way is like we can like use it as a simple computer by attaching the HDMI cable in it and attaching the other end of the HDMI cable to the monitor, and we can just simply connect our USB keyboard and mouse in it and use it as a simple computer. But like at each and every time, I cannot carry a laptop and go to the deployment side and use it as a simple computer. So other way around is like we can use an SSH connection, or I can use as like a kind of serial bus through which I can transfer the stream of commands into it. So for that specific thing, I have a tool named as Putty. So Putty can easily be downloaded. Like if we can simply search Putty over here. The first link, that is the putty.org, gives us the downloading link. So yes, by clicking over here, we get the downloading link. I get the exe file setup, and after completing all of that thing, our Putty is like kind of this one. Just a minute. So yes, we kind of like this kind of specific window is open over here. So there are basically two ways to connect with the our hardware. One is the SSH. So SSH can be used in the scenario where my Jetson and my local laptop shares a same connection. Like they both of them are in the same Wi-Fi network or WLAN network. But the other way around is the serial network. So in this specific part, I am using the serial network where I have used a USB type A cable attached to my computer and attached with the other end of the NVIDIA Jetson. So like I can easily pass the stream of commands through this wire. So like to identify the serial line, like specific line from which my data should be, or line, or be in the technical language I will say the bus from which bus my command should be go through the wire to the Nvidia Jetson. So this can be like after configuring the hardware, we get this in the device manager. So device manager is the place where we get the hardware info. So in this, the if in the ports info we get this, the at present the USB serial device COM3 line is activated. So COM3, yes. So over here I have to just replace COM1 to COM3. The speed we can use it as the same default, but yes, if the command size is high, or if you have the dedicated wire where high speed transfer is kept, like it's capable to do a high speed transfer rates, so we can increase the speed over here. But yes, I am using the symbol by default value over here, and like as soon as I open it. So yes, as soon as I open it, I get my terminal of Jetson. So like simply I am logging myself into the Jetson part. And yes, over here is the Linux terminal. So this terminal is same as that has been used in Ubuntu, because our Jetson is has Ubuntu 18.04 like LTS version installed in it. So all the commands of help, sudo help, and all of that commands are already be there. So all of these things can easily be executed through this terminal. So like okay, like I can use the cd ls commands for accessing the corresponding directories. Then I can use cp command, rm command. Like yes, yeah, I am not specifying the directory, so it's giving me the error. But as soon as I specify, like yes, all of the Ubuntu commands can easily run over here, because it's just basically a Ubuntu terminal accessing through our local hardware or local machines. So after doing this, I will like so till now we have completed installation of PuTTY and the SSH connection with the explanation of SSH connection with the Jetson. Now other way is the file transfer. So for deployment part, either I can create a Docker container. That's the thing we have basically done in this project. The other way around is that I can just create a TensorFlow based model. After that, I will convert that specific model into the TensorRT to use the less amount of resources, and then like I will zip the whole file, and I can either upload it on the I can either upload it on the drive and use the wget command to download that specific file on my Jetson, or I can like okay, I can zip my file, use my USB to transfer that specific file into the Jetson. So either of the way, like it's the choice of the user or the end user who wants to do that specific deployment task. So like there are other ways as well that can be explored in the web as well. But yes, these two are the main ways that like these two ways are the common in the practice. So like after like I have already learned the Docker pull command over here. As you can see, like yes, here is our repo. So the this particular repo is available on the Docker Hub. You can directly use this command to try and test this hardware on your local machine. So after that, after like okay, now I will just run my Docker file over here. So just a minute. So like okay, I have just put my Docker command over here, like it's a Docker run, then port number and all of that stuff. After that, the file we have just containerized, it will start like running. So it's the same file as the Python final.py running in my local machine that I have explained it as before. So like okay, now it's allocating the resources and giving us the logs, like required logs. These logs can be either saved in some specific part. So like the other way around, we are also saving this particular video generated the during after the processing of the after the rendering part, we are also saving it. So that specific thing can also be accessed to a specific URL. So yes, over here the info is there. I have to just drop this URL on my browser, and yes, it will start the streaming of the video over there. And the video is of like 100 frames, like 100 frames. As soon as the 100 frames got processed, it will save it as a video file or MP4 file. As you can see, that is continuously saving my MP4 file in the hardware. And as soon as it got processed, my hardware, like the RAM which has been used, got free. So in that way, it's completely working fine. So okay, here ends the presentation part. Thank